From our previous class that we had, we managed to work on a quadratic where we are going to differentiate this type of a quadratic using the first principles or the definition of our derivative. So moving on, from our previous segment, we are going to consider this time a cubic function of this format. Y is equal to ax cubed as part of our syllabus. The idea is still the same. From the first principles, remember your formula, all right? Let's say for an example, let's say, all right, let's just put an example here where we are going to differentiate, or to find the first derivative with respect to x from what? From first principles, or from the first principles, all right? Let us say this is what we have. If f of x is equal to 2x cubed. So for you to understand much better, make sure that you do watch the previous classes that we had on the first principles, all right? From the definition of a derivative, that can help you a lot, as this part is a continuation from what we had. So when you are given this, remember I said you need each and every part of the formula that you give. This is the formula, and you're given this in your formula sheet. You've got this formula, so do not worry. Already f of x is given. This is what you are given as if f of x is equal to this. So meaning to say on our formula, f of x is given. What we need is the function of what? F, this x plus h, f of what? X plus h. So thus we are going to need f of x plus h. All right, let me just do this. So here I'm going to need f of x plus what? Plus h, which simply means in place of x on our f of x, in place of x, you are supposed to put what? X plus h where there is x there. So this is going to be 2 into what? X plus h here in place of x. So it's gonna be x plus h to the exponent of what? Of 3. So we have substituted this. That is where we had what? X. This is what it simply means. Now we expand this bracket as before. Remember when it was raised to the exponent of 2, you already know, guys, x plus h squared. That was our previous class. We dealt with this part. And when we expanded, we said we're just going to use the concept of what? A plus b squared that you are used, or x plus y squared, the one that you are used, which is going to give us x squared plus 2xh plus what? H squared. This is the condition of what? A bracket raised to the exponent of 20. You're given two terms, x plus h, a plus b, x plus y. You can use this expansion as we had before in our grade 11, grade 10 there. So some of us, or some of you guys, even for x plus h cubed, you can also expand it, because remember, a plus b cubed is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. All right, it's just like an identity. These are identities under algebra that each and every one of you guys must know or memorize. You end up even knowing what's happening. So if you check, okay, let me just explain this one for the sake of revision, but I was not supposed to do that. Let me just do this so that we understand what is happening here. If you check, it's a cubed from the first term, this one. It's a cubed raised to the exponent of this. Then it reduces a cubed. Now it's a squared. Now it's a on this part. It was supposed to be what? A to the exponent of 0. We do not have it. That's why it is 1. And b, the last term opposes from the last part here. B to the exponent of what? 3, this exponent. B to the exponent of 3, reducing b squared, b, and this was supposed to be what? B to the exponent of 0. All right. And I think for the numbers, guys, you can note 1, 1. This is 3 and 3 in between. Like if you want to memorize something like that. So you could have used this. So meaning to say when it is x plus h cubed, you're just going to put x in place of a. So it's going to be x cubed plus 3x squared h plus 3xh squared plus h cubed. You are done by knowing your algebraic identities. But let's say I do not know this. What can I do? All right. To expand this, it simply means these are 3 brackets of x plus h. Just like 2 to the exponent of 3, it means 2 times 2 times 2 to the exponent of 3. It is going to multiply itself what? 3 times. So now take a bracket of what? X plus h raised to the exponent of 3. It means this bracket is going to multiply itself what? 3 times, like this. That is what it means. So meaning to say, you can expand direct. You can expand this. So let us start with the 2 brackets at the end. That's these 2 brackets. Let's expand these. Are we seeing x plus h into x plus h? It is the same as this. X plus h squared. So we're going to obtain this part. This is what you're going to get at the end. And for expansion part, guys, I dealt with this one in the previous class, where x is going to multiply here, it multiplies here, h is going to multiply here, it multiplies here. Remember our previous class, we dealt with this one. So this is what we got, x squared plus 2xh plus h squared, like this. All right, this is what you are going to have at the end by expanding these 2 brackets. Now we have got this bracket to expand the second bracket. So as usual, what is in the first bracket multiplies everything in the second bracket. So you're going to take everything in the first bracket. There is x and there is this plus h. So we start with what? X, multiplying each and every term in the second bracket. So x times x squared is going to give us x cubed. All right, then x and 2xh. So take note, there is x there. So x and x is going to give us what? X squared. So it's 2x squared, x and x. Then we're going to have what? H. Then the sum, x multiplies the last term, h squared. So it's going to be x h squared. So this is x h squared. We are done with the first term. Then we move on to the second term, which in our case is what? H. So h times x squared. Using this order where we started with x followed by h, it was supposed to be hx squared, hx squared, but we are going to start with x squared, all right, just for the sake of like terms so that you can properly see your terms. So this was going to be plus x squared h. All right. The same thing here. It was going to be h times 2x h squared, 2xh, this one. So h and h is going to give us what? X squared, 2x h squared. H times h. All right. So that's going to be 2x h squared. And the last one, h is going to multiply what? H squared. So that's h times h squared, which is going to give us h to the exponent of what? 3. You simply add the exponents. Remember, when you're multiplying, simply add what? Your powers. So this is what you're going to have on this expansion. Then you have to collect the like terms. So let's collect our like terms and see if we're going to have exactly this answer that we could have obtained by knowing what you are dealing with, your identities. So collect like terms. All right, let us just collect like terms. Okay, which in this case, we can see that there is this part of x squared h, x squared h, x squared h. These are like terms, x squared h. Same variable and power must correspond. So you add the coefficients of these. So this is 2 and this is a 1. So 2 plus 1 is going to give us what? It's going to give us 3. So this is 2 plus 1, which is going to give us 3. So that's 3x squared h, as it is the part of what? X squared h. Those are your like terms. Then another part of your like terms, if you consider same term, same power, x h squared, x h squared. These are like terms. X h squared. This is also x h squared. So you add them. So here the coefficient, since we do not have anything, is a 1. So that's 1 plus what? Plus 2. So you add these two. 1 plus 2, which is what? 3. So that's 3x h squared, as it is. Those are like terms. As we can see, we are done with the part of like terms. So we are just left with this last term, h cubed. And this one is not a like term. It is not like to be added to any other term. These are not like terms, guys. This is x squared. This is x. The like terms must also have the same power. If it is x squared, this one also must be x squared. If it is x squared h, x squared h, these are like terms. Same power, same variable. H and h, this is x. And if the powers are different, remember we said previously, those are not like terms. They cannot be added. So most of you guys, you end up adding these two. No, be very careful, especially under exam. Check properly, guys. This squared, this one it's on x, this one is on h. They are not the same. They are different terms. They cannot be added. So that is the expansion of what? X plus h to the exponent of 3. So as we can see, this is exactly the answer that we are having from our identity here. But this was from expansion, if you are to expand. So it is in your hands how to expand that. That is the purpose of this class, so that you know that any part is acceptable. So you can expand it using this way. It is up to you. For some, they can just use x plus h into x plus h squared, where x plus h squared is this answer that we got here. It is still one and the same as writing it in this manner. All right. So that is it. Let us take this one to our expansion of x, f of what? X plus h. So it's going to be 2 multiplying this bracket raised to the exponent of 3. So the 2 is going to multiply the answer that we obtained from the expansion of this. Remember, guys, when we expanded, this is what we got, or any of this is just one and the same answer. So put it this way. Here, so it's x cubed plus 3x squared h plus 3x h squared plus h cubed. So this is it. So that is the idea. You have got to what? Your f of x plus h. by expanding each and every term by what? By 2. 2 has to multiply each and every term inside the bracket. So that's going to be 2x cubed. 2 times 3, that's 6x squared h. 2 times 3, that's 6 again, x h squared. 2 times 1 here, that's a 2h cubed. So this is our f of x plus what? Plus h. We leave it as it is. Yes, you can find the difference between these two. It is up to you, or you take it to the formula, then find your difference there. So the formula is stating that if we are to calculate the derivative, if we are to determine the first derivative as we are given here to say we have got this one. Okay, let me bring it down. Let me bring it up like this. Like as we have got on our example that we are supposed to find what? The first derivative from first principles. We're going to use our formula, or like everything that we need on the formula is what? Is there. So substitute into the formula straight. The first derivative with respect to x from our formula is this, that is going to be f of x plus h here, minus f of x, everything over h like this. We're going to substitute. We've got everything. Our f of x plus h is there. So that's going to be limit as h approaches to 0 of f of x plus h. Take this part here as it is. That's going to be 2x cubed plus 6x squared h plus 6x h squared plus 2h cubed. This is our f of x plus h. Minus what? F of x. So that's minus our f of x. This is the original function that you're given, which is what? 2x cubed. So you subtract that, 2x cubed. Everything over what? Over h. Remember your steps. You have substituted your f of x plus h into the formula, and your what? Your f of x. Then subtract where it is what? Where it is possible in terms of the like terms. We have got what? X cubed here, and also x cubed. Those are like terms. So we can simplify that. So that's 2 minus 2 is going to give us a 0. So it's already eliminated. So you're going to remain with these terms as they are. So it is going to give us 6x squared h plus 6x h squared plus 2h cubed. Everything over what? Over h. Remember what I said from our previous class, that we cannot substitute this limit of h, which is approaching to 0, when we have it in the denominator like that. We must get rid of that. So meaning to say, we must simplify the numerator, then cancel with this h in the denominator by what? Factoring out the h, or separating the terms. 6x squared h as it is over what? Over h. Then the next term plus 6x h squared over h plus the last term separate. It is in your hands. You can do it this way. Then you can cancel h and h. You've got 6x squared, h into h squared. You're going to remain with 1h. h into h cubed. You're going to remain with 2 of these h's. So you've got eliminated or used the h which was in the denominator by what? Separating. But this is not the only way that you can work out of separating your terms. No, you can actually do this by what? Factoring out the h. All right, you can factor out. Another way, you can simply factor out the h which is common in the numerator. As we can see, we have got h, we have got h, we have got h. So it is common. So we can factor it out so that we can cancel with this h in the denominator. So factor out h. This is going to give us 6x squared. Factor out h. There are 2 of them. So you're going to remain with 1h. Here there are 3, so you're going to remain with the 2 of them, all right? Everything over h. So you have taken out h from this. That's creating a bracket where the h and the h can cancel. Remember, your product allows us to cancel these two. So meaning to say at the end, you are left with what? You are left with this 6x squared plus 6xh plus 2h squared, which is exactly what we had here, which is exactly what we had from separating the terms with what? The h in the denominator. So it is in your hands. How are you going to get rid of that h? Now that we do not have the h in the denominator, let us apply our limit as h is approaching to 0, meaning in place of h, we must put a 0. So this must be 0, 0 in place of h. So it was going to give us 6x squared plus 6x times 0. All right, this is h, which is 0 plus 2, 0 squared. So this is going to give us a 0. This is going to give us a 0. So at the end of the day, we are going to have 6x squared as our first derivative from our f of x. This is the first derivative of what? F of x, which is what? 6x squared. From the first principles. You use this when you are told from first principles, you apply that. Otherwise, you are supposed to use the general rule, which we are going to talk about later on. But for the first principles, that is the idea for any cubic function, for any, because it's part of your syllabus, guys. You know that this is part of your syllabus. It is best that you just memorize, if you can, memorize this expansion of what? X plus h to the exponent of 3. Know it. Because it's part of your syllabus. Just the same way that you understood this one, you can also understand this. But if not, do not be limited in exam. Expand up to the last part, okay? Expand these brackets in a way that you understand. That is the idea. And not forgetting our formula. We must know our formula, how to apply the formula, how to use it. How to use. F of x plus h must be there. And also f of x, which is the original function. You put that, subtract. If you're having terms, like if you're having an expression, once you put the negative, open the bracket for that expression. Maybe it was 2x cubed plus 3x squared, whatever that you're given. You open a bracket so that the negative affects every term. But here it was just a single term. There was no need of opening a bracket there. Yes, you can do that, but there's no need for what? A single term. So that is the idea. So I want you to use this idea, guys, to answer any question of a cubic function of a cubic, all right, that you'll be given where you do not understand. That is the purpose of what? Of the comment section. We communicate from there so that we can understand each other on the questions that are still giving you a problem. But for now, that is it. That is it. Till we meet again.